So we started discussing about IP routing concepts. IP routing is a process of moving IP traffic from one network to another network, and IP routing involves two basic activities. So basic activities are finding shortest path and forwarding the packets to this shortest path, and routing conditions, routing types, static routing with them. So before starting to dynamic routing, let's understand about once again static routing, advantages and disadvantages. See, this is the topology. If we configure static routing in this topology, let's say H is 10 dot 0 dot 0 dot slash 8 network. Slash 8 means it's a default network, default mask, right?
Yes, sir.
Yeah. Okay. See, if we configure static routing, the first thing is a routing table. A routing table. So B networks information, C network information, D network, and B2C, sorry, B2E WAN link, and E networks, F networks, G networks, H networks between this network. These all destination networks we need to update manually or automatically.
Manually, sir.
Yes, sir.
Manual updates,
Really?
no auto updates. So how we can update these all destination networks? We should know what is
Yes.
B network, what is B to H network, and what is H network. We should know, right?
Yes.
So I should know DST, destination networks. Agree?
Yes, sir.
Yes.
Yes. So from A to H scenario, in A to H, from A LAN users is trying to communicate with H, A to H scenario. How many paths are available? So
3.
traffic can exit via 0/0. So traffic can exit via 0/1. So multiple exit points are available, right?
Yes, sir.
So which one is the best exit point? Which is the best
0,
path?
0.
0,
0,
0.
0.
That something we need to decide. We can't say simply 0/0.
Sir,
It can be 0/0, it can be 0/1, it can be 0/2.
yes.
Like admin can decide the parameters maybe based upon number of hop count or based upon bandwidth or based upon security, based upon reliability, based upon can be any. Got it?
Yes, sir.
So best path selection by admin. Admin has to decide actually, correct?
Okay.
Let us say as you said 0/0 is the best path. Just for example, you consider 0/0 is the best. Then how can write the static route?
I,
IP route.
test
Destination is
like
10 dot
this.
network and
Some
mask is
mass
255.0.0.0. And out of three exit, which is the best exit
serial.
point?
Serial 0,
Serial
0.
0/0. Now, in your routing table, 10 dot network is statically updated. Traffic should go via 0/0 is the then traffic is going via 0/0 and reply will come back in the same path. Correct?
Yes.
So what after some time if serial 0/0 is failed? Your best route is down. Your best path is failed. If 0/0 is failed, then A users and H users will they communicate?
No.
No communication. Downtime.
Bro.
Until unless we need to change configuration again, we need to reconfigure IP route standard network 255.0.0.0 serial 0/1 until unless no communication. If best path is down, second best path manually we need to find action, right? Manually we need to configure. Whenever 0/0 is down, then configure 0/1. Then traffic will go via 0/1. Reply will come back in the same path. Your routing table also will be updated. Like what if your best path is up, your 0/0 is up now, then how traffic can reach via 0/0? Again to reconfigure 0/0.
Reconfigure.
Yeah, like when any new network is added in topology, new network is a say 9 dot network. So this 9 dot network, it will come automatically in routing table or manually we need to update.
Manually, we need to update it.
Manually update in each router, in B router, C router, D router, in every router, right?
Yes, sir.
Yes. So this is how static route works actually. Everything is manual updates, no automatic updates. We should know all destination networks. Best path selection by admin manually. If best path is failed, second best path selection by administrator manually. So network administrator work is more. This is why it is recommended only for small and fixed networks. Got it?
Yes, sir.
And now we'll start with dynamic routing.
Dynamic.
Dynamic routing. If you configure dynamic routing in the same topology instead of static routing, the first point is automatic updates. In static routing, manual updates, right?
Yes, sir.
Yes.
In dynamic routing, automatic updates. Means router B networks will come to your routing table automatically. You just configure dynamic routing in A in all routers, then B networks information, C networks, H networks, between the networks, all indirectly connected networks information you can see in your routing table automatically. Within a second, so you can see that information actually.
Okay, sir.
If all destinations is coming to your routing table means, is there a requirement to know your destination networks?
No.
No.
No need. So no need of destination networks, no need to know. And how many paths from A to H?
3.
Three
3.
paths. Out of three paths, protocol will find the best path automatically. Your dynamic routing will find it is 00 or 01 or 02. Your protocol will decide actually. Example 0/0 is the best path and traffic is going via 0/0. Whenever 0/0 is down, automatically within a seconds, dynamic routing protocol will forward the traffic via second best path. If best route is failed, within a seconds, dynamic routing protocol will find the second best path and traffic is been forwarded actually. Get it?
Okay, sir.
Yes, sir.
I didn't get that. Is it going to switch if that cable is down? Will
Yes,
it will switch to another cable by itself?
correct. That is automatic happening to me. Well, that is what I'm trying to explain here. Whenever this cable is failed, then dynamic routing protocol within a seconds will switch the traffic to another link, another best, without any more downtime. It is happening dynamically, automatically. So after some time, your first path is up, then traffic will switch to first path only. So everything protocol will manage. As a network engineers, our part is only initially for one time we need to implement the protocol. That's all. Then protocol everything is been. If any network is added, new network is added, then this 9 dot network will be updated in all routers routing table automatically.
I'm
9
sorry,
dot
sir,
network
to
is failed. If 9 dot network is failed, then automatically 9 dot network information will be removed in all routing table. So any changes happens in the topology, automatically updates. Yes, Murphy, please.
is this a mesh or star connection?
Topology.
It's mesh, not star. So, like any changes happens in the topology, dynamic updates. Any small change, if link down, then all router will get log message, so and so on router B link was down. Like how all routers will get the update means entire dynamic routing protocol works with neighbor, neighbor relation. So there is a change in router B. So what is the change? New network, which is 9 dot network, is added to which router? Is connected to which router? B. So you know what B will do? Like for B, which routers are neighbor routers? Neighbor means directly connected device. For
Yes.
B, A is a neighbor, H is the neighbor. So what B will do is B will update. B will inform to neighbor, hello my neighbor A, you take one update which is one 9 dot network is added in my router and it update to H also. So what A will do? A will update to their neighbors. For A, which are the neighbors? C is the neighbor,
C.
D is
And
the neighbor. C what will do? D will what will do? Update to neighbor. Like neighbor to neighbor, neighbor to neighbor, entire all domain, like hundreds of routers will get that information within a seconds automatically. So your neighbors are maintaining the 9 dot network. Every router maintain what? 9 dot network. 9 dot network is available. Okay. Now what after some time 9 dot network is down? Then again B router inform to neighbor, neighbor router, before I update to 9 dot network. No, that is a false information. You remove it. It is no more, it is down. Then A will also remove it. After removing, and A will inform to neighbor, neighbor C and neighbor D, you remove a 9 dot network, 9 dot network, like all routers will be removed. So any change in the topology dynamically updates. Path selection automatically. If path selection is down, best path is failed, second path selection also automatically. Destinations are no need to know. So network administrative work is more or less.
Less.
Less. So which type of topologies, which type of networks dynamic routing is recommended? For small networks or medium networks or large networks?
Medium
for
and
any
large.
type.
Medium
Any
and
type.
large, any type of course. We can configure, right? Now compared to static routing and dynamic routing, which one is the best?
Dynamic.
Dynamic.
Tomiwa,
Sir?
which is the best compared to static routing and dynamic routing?
Dynamic.
Dynamic. Murphy.
Dynamic. But
Uh,
I want to ask you a question, sir.
yeah, please,
That
please.
nine dot, it has only one wire. So if it fail, how is it going to get the
No
support?
communication. If it is only one way, then no communication. We need to maintain the backup. Redundancy should be maintained. This is 9 dot network connected to be in single wire. Just I explained for example, like any change in topology, it will update automatically. For that, I took the example actually. Srikanth, Shyam, Tarun,
Dynamics.
which is the best? Dynamic.
So a static IP and dynamic IP also be like this one. Okay.
Static IP, dynamic IP is different. This is routing. We are discussing about dynamic,
Okay.
static routing and dynamic routing.
Okay.
Yeah. Dia, Salma, Atul, what do you say?
Yes, sir. Clear, sir. Dynamic is best.
Dynamic is best. Come on, man. See,
Sir, but one thing is there.
okay.
Security is less, sir, but
Security, excellent. Exactly. See, point is, in static routing, who will find the best path?
we, I mean,
Admin will find the best path.
yes,
In dynamic, who will find the best path?
automatically protocols.
Automatic.
Protocols.
Protocol will decide the best path, na.
Yes, sir.
So we don't know protocol will decide which way is the best path. But in case of static routing, as administrator will decide the secure path, fastest
Yes.
path.
Yes.
So compared to dynamic, static routes are secured.
Yes, sir.
Agree? Because admin is deciding the best path. And one more point is, in dynamic routing, there are automatic updates, right?
Yes, sir.
Example, 9 dot network is down. Then what we will do?
It will switch.
Switch to other means dynamic
If
auto.
any change happens, B will update to all routers, right?
Yes, automatically it will
So
update.
A will update to all routers. C will update to all routers like that. What again? A 9.8 is up.
Again, it is update.
Again, all routers will start sending
Update
updates.
again. Yeah, it
Again,
will
it
update
fails.
again.
Again updates. Again it's up. Again updates. So dynamic routing protocols, if any small change happens in the topology,
To
all
update.
routers will start functioning.
Correct.
All routers will start sending updates. Means there is CPU utilization, processor utilization, and bandwidth utilization will be more because it has to be send update every time.
Yes, sir.
So we purchase a bandwidth actually, right? So
Yes,
that
sir.
bandwidth is consumed by what? Protocol updates actually. Got it?
Yes, sir. Yeah.
In static routing, do you have any automatic updates?
No.
No.
No,
No
that's
automatic
not
updates means no wastage of bandwidth. Whatever the bandwidth is available, that bandwidth effectively we can use for data transmission purpose. So if you use complete bandwidth for data transmission purpose, then faster communication you can see.
Yes, sir.
So that is the point here. Static routes are secured, reliable, faster, no wastage of bandwidth. But drawback is it is recommended only for small networks. A small network means the best is a static routing. Because secured, faster, reliable. The bandwidth is not wasted. Complete bandwidth you can use for data communication purpose. Agree?
Agreed, sir.
Drawback, no automatic updates. We should know destination network ID. Admin work is more used in small networks. These all are disadvantages. Similarly, tell me about dynamic routing advantages,
Auto update.
Automatic.
automatic update,
Destination IP not required to know.
destinations are not required.
Auto
Okay, good.
updates.
Admin work
Auto
is low.
updates.
No admin work.
Administrative work is less. Okay.
Uh, mm, disadvantage is less secure.
No, I'm not asking about disadvantages. Just tell me disadvantages.
It's easy to program.
Easy to implementation. Okay. Correct.
If new network is
Finding best path.
finding
If
best path
best path is
automatically, yes.
fail,
It will choose another best.
Another
it
best
will
path
choose
is
automatically second best path. This is
Automatically.
very beauty in dynamic routing, right?
yes, sir.
Yes. So if any one link is down in your organization, within a seconds, automatically traffic is being switched to second best path and traffic is being forwarded.
Yes, no downtime.
See, at any time, if you have internet, we are accessing Facebook server. At any time, you are accessing Gmail server. How it can be possible? Do you think you have our link is always up?
No.
No.
No. Sometimes link will fail. Still, we are communicating. How?
Another routers.
Another best path. So this action, this is taking care about by what in backend?
Routers.
Dynamic protocols. Protocols is taking care about action. Automatic updates. Changes in topology, automatic updated. Only directly current network information is required for configuration. It means no need of destination networks. Less administrative work. Selecting best path to destination networks. Finding second best path if best path is no longer available. More scalable, so we can use this dynamic for small also medium large enterprises, very large, used to generally used for medium and large enterprises. Clear?
Yes, sir.
So these are about differences between static routing and dynamic routing. Static routing advantages, disadvantages, and dynamic routing introduction, dynamic routing advantages. Any doubts, guys, between these two?
Also,
Sir, I have one doubt. How large organizations will maintain the dynamic routing with this less security? They are using any alternatives for this?
Security. We are not discussing about security. Whenever network security will come in the picture, they will maintain some other devices called firewalls.
firewalls.
This is only for path selection purpose. It is
Yeah.
only for maintain the routing information purpose. Got it? Yeah. Yes. Dynamic routing. We have two categories in dynamic routing. Interior gateway protocol called IGP and exterior gateway protocol EGP. Two categories in dynamic. IGP and EGP. IGP protocols are again three categories in IGP. Distance vector protocol. Distance vector protocol DVP. Link state protocol LSP. Link state protocol. Again distance vector protocol. What it is? Advanced distance vector protocol. EGP, in EGP have only one category. Is path vector protocol. Actually, in DVP, in distance vector protocol, there are two protocols comes in the distance vector protocol, which is RIP, routing information protocol, IGRP, interior gateway routing protocol. So this both comes under distance vector protocol. In link state protocol, have two protocols. OSPF, open system, sorry, open standard, open shortest path first. Okay, don't get confused. OSPF means open shortest path first. Next, ISIS, intermediate system, intermediate system. In advanced distance vector protocol is EIGRP, enhanced interior gateway routing protocol. In path vector, have protocol is border gateway protocol, which is BGP. These all are different type of routing protocols we have. Point is, IGRP is no more. IGRP is modified into EIGRP. It is enhanced. No IGRP. See, this is IGRP. It is enhanced. E means EIGRP. Enhanced Interior Gateway Protocol. So no IGRP. Like ISIS is also modified into OSPF protocol. In CCNA level, in syllabus we have only about OSPF protocol. But for knowledge purpose, I will explain about RI protocol also. Okay,
Okay, sir.
and EAGRP, BGP, these protocols will come in CCNP level. Let us more focus. Like today, we will complete about RIP protocol, and almost we have 2 sessions for OSPF. We'll go very advanced level and very detailed about OSPF protocol. Complete in and out. We'll discuss about OSPF protocol in CCNA level.
Sir, in organizations or enterprises, which protocol we are using, sir?
So in organization real time, we use OSPF protocol majorly for EAGRP and BGP. These 3 protocols we use in real time. But most of the organizations having what protocol is OSPF.
Which one is the best, sir?
Which one is the best means if you know the protocol behavior, then you can decide which is the best, right? You can't say right now actually.
Sir.
You should know about how RIP works, what is the algorithm of RIP and how OSP works, how EAGRP works, and you can compare 3. Then you can decide.
Yes, sir.
So how you are telling static is the best and dynamic is the best because of you know about static routing, you know about dynamic routing. Then you can compare and decide yes, static has some advantages because it is a secured, no wastage of bandwidth, reliable, faster. Then you can say static is the best. At the same time, but static is recommended only for small networks because administrative work is more, no automatic updates. Similarly, in dynamic also has some advantages. Automatic update, finding best paths, finding second best path. If best path fails, so any changes happen automatically. So it seems to both have a separate advantages. Then dynamic routing will go with the medium and large networks. So once if you know 2 routing protocols, then you can compare and decide which is the best, right?
Yes, sir.
Actually, which is the best is not a right question actually. Where we use static routing for small networks is recommended. So where we use dynamic routing, medium and large networks. Like we can't say static is the best, dynamic is the best, not like that.
Yes, sir.
Both we
Based on
use.
requirement.
Both are need actually. Based upon our organization scenarios, we can use the both. Got it?
Yes.
Similarly, like RIP, OSPF, EHRP, which is the best means it depends. RIP has some advantages and drawbacks. OSPF advantages and drawbacks, EHRP. So if you know all dynamic routing protocols, then you can have idea. Oh, so and so environment RIP is the best. For so and so environment OSPF is the best. Like you can decide actually. Okay. Ten dot 1.1.1/8. Which class IP address it is?
A.
Class
A.
A. /8 means is it a default subnet mask or
Default.
customized subnet mask?
Default.
Default, sir. Default.
10.1.2.1/16. Which class IP address it is?
A.
Class A, but subnet mask is customized. Yes, sir.
It's a customized, right?
Yes.
10.1.3.1/24. Which class IP address?
Class A, customized subnet mask.
10.1.4.1/29. Which class?
Class A.
That's A.
What is the differences between first one and remaining 3 IP addresses?
Subnet mask is
Subnet mask.
customized.
First one is not subnetted,
Yes.
right? It is not subnetted. It is not customized. If IP address is not subnetted, if it's not customized, then you can say it belongs to class A or class B or class C because for class A, first octet is what?
And
Network.
Network.
Host,
Host.
host,
Host.
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 Same /8 means N hash hash hash, right?
yes,
Then we can say this type of networks we called class full networks. So class is available A, B, C
yes.
category.
Classful, yes, sir. Yes, sir. Classless. Sir.
Class full networks. What about these networks?
Classless, sir. Actually, CIDR category.
So this is all are customized. Is not comes under class A, it is not a class B, it is not a class C.
Yes.
Based on our organization requirement, we customized it actually. So once IP address is subnetted, then no more classes. It's a classless
Yes, sir.
classless networks. So two types here, classful and classless. Classful means is not subnetted. It does not support for subnetting also actually. Classless means is subnetted, customized. So once it is customized, then we cannot say is a or B or C. That's simple. We take one network, it can be from B or it can be C, it can be A, and customize based upon requirement. That's all. So classful and classless. Classful routing. So classful means it does not support for subnetting. Classless is what? Support for subnetting. Similarly, in dynamic routing protocols, we have classful routing protocols, classless routing protocols. The protocols which are classful routing protocols does not support for subnetting. Classless routing protocols support for subnetting. Like in RIP, we have two versions. RIP version 1, RIP version 2. Like why IGRP is outdated? Because of it's a classful, it does not support for subnetting. IGRP protocol, RIP version 1 is all classful routing protocol which does not support for subnetting, whereas remaining all protocols are classless routing protocol. They can support for subnetting. Like RIP version 2, OSPF, EHRP is all are classless routing protocols. Classful routing protocol does not support subnetting, which is RIP version 1 and EHRP. Classless routing protocol supports subnetting, RIP version 2, EHRP and OSPF. Got it?
Yes, sir.
So today we'll try to complete about RIP, Routing Information Protocol. It's an open standard protocol. It's a distance vector protocol. What do you mean by open standard?
Free to use.
Hmm?
No need to pay. Open.
Mhm.
Anyone can use, no proprietary.
Yes. Open standard means we can configure RIP protocol in Cisco routers, in D-Link routers, in Juniper routers, in MIPO routers, in multicom like HP routers. So open standard protocols can support for multiple vendors. But whereas protocol, proprietary protocols will be there. Means that protocols will be working only that vendor.
Yes, sir.
Is it RIP is like that?
No.
No, it's open standard. It means its advantages or disadvantages?
Advantage, sir.
Advantage. Remember, please remember advantages and disadvantages of RIP protocol. Today I will explain very clearly about RIP protocol, because if you understand clearly about RIP, then next OSPF protocol is very simple to understand actually.
Okay.
Get it?
Clear, sir.
So RIP first advantage is what?
Open source.
Open standard protocol. It can support for
Any.
multiple vendors. Done. Next point, algorithm name, the scientist name, the developer name is Well-Manford. So use this Well-Manford algorithm. RIP, is it a classful or classless?
Class depends on version, sir. V1, V2.
Which is the best?
V2.
Classful or classless?
Classless.
Both.
Classless.
Classless.
So forget about version 1. It is outdated. Leave it. Then RIP is classless or classful?
Classless, sir.
Classless. You forget about version 1. It is not support for subnetting. So you can say RIP version 2, classless routing protocol. It supports subnetting. Means its advantage or disadvantage?
Advantage, sir.
Advantage. But point is, all dynamic routing protocols, RIP, OSPF, EHRP, all dynamic routing protocols, pass selection automatically or manually.
Automatically.
So how RIP will find the best path? Based upon what parameter RIP protocol will find the best path? That is what we
Distance
need to
vector.
discuss actually. See, in this topology, and scenario is the same scenario, which is A to H.
Mhm.
how many paths are available?
3.
Traffic can go via serial 0/0. Correct? This is one
Yes.
path. Or traffic can go via 0/1, another path. And traffic can reach via 0/2, 3 paths are available. For example, traffic is going via 0/0. So 0/0 traffic is handover to which router?
B.
B. B handover to which router?
H.
H handover to?
G.
No. Why G? Our destination is A to H scenario, na?
Yeah, exactly.
Destination is H LAN. So H handover to where?
LAN.
LAN. So means from 0/0, your data traffic is handovering to how many routers?
1.
0/0 handover to B, B handover to
That's 2.
H. So how many handovers packet?
2.
2. This count we called hop count.
Yes.
So RIP protocol will find the best path based on what?
Number of count of
Hop count.
Hop count.
Oh,
HOP. Hand over packet count. Got it? Hop count. Hand over packet. How many handover packets? B, H, 2 hop count via S00. What if traffic is going via S01? S01 handout to C, C handout to E, E handout to H. What is the count?
3.
4,
So
3.
distance is 3. The count we call distance actually. Distance is 3. Via 0/2? D, F, G, H. What is the distance?
4.
4.
4. So RIP will decide least hop count is the best path. So which is the best one? As per RIP,
2.
0.
0.
0/0 is a best path. So traffic will go via 0/0 and reply will come back in the same path. Like what after some time if 0/0 failed?
Switch to another best.
So there are 2 paths are available. So which is the
Three.
second best? 3
3.
or 4?
3.
3. So then traffic automatically within a second traffic will go via 0/1 and reply will come back. Again your 0/0 is up. Then again traffic will go via 2 hops actually. This is what happening in RIP protocol. So RIP protocol will find the best path based on what?
Number of counts.
HOP.
Hop count. That is what we call technically metric. Metric means one of the calculation to choose the best path. So every protocol have a different metrics, different metric calculations. RIP hop count. OSPF is a different. EHRP is a different. BGP is a different. So every routing protocol have a different metric values, metric weights. So we are done with about hop count. Got it? Yeah. Say 1, 2, 3, okay. See, all are connected. All routers are interconnected. So this is only one path you have. We don't have a multiple paths, only one path, 0. So ultimately traffic should go via 0 only. This is R1, first hop, R2, second hop, 3, 4, 5, 6. Between, let's say many hops are available. Many more number of hops are there. in between, and it is R15 and it is R16. So this is my source and it is a destination. From source to destination, how many paths are available?
15.
Paths, not hops. How many pathways? How many?
One. Only one.
Only one path. So traffic should go via
Only one path.
S0 only.
S0 only.
So data packet is being generated here and it is going to, it is hand over to which one first?
R1.
R1. Means one hop count.
Yes.
R1 hand over to
R2.
R2. R2 to
R3.
R3, R4, R5, R6, R7. Like it received which router, which hop?
15.
15. And R15 will do what?
R16.
R15 will drops it. So RIP protocol maximum handover packet, maximum hop
Okay.
count is 15 only. It cannot reach more than 15.
So 30, I think we have.
15 hops. RIP protocol maximum hop count is what?
15. Okay. Yes.
15. But what is my destination?
16.
If I use RIP protocol, can I reach 16th router now?
No, sir. No.
No. So you want to use RIP protocol, you make sure that your destination router should be within 15 hops only.
Oh.
If your router is the 15th, more than 15, 16, 17 hops, no, cannot be reachable. The RIP protocol designed, developed by like that actually. Algorithm itself is working like that. The behavior is that. I already handed over maximum I have reached 15, 16th I cannot reach.
Okay.
Drops it. So means is it drawback or is it advantage? What you say?
Drawback, sir.
Drawback. We can't use for medium, no more larger networks, right? Yeah. So maximum hop count is 15. 16th is unreachable. Clear?
Yes, sir.
Yeah. Okay. The next point is let's see this. This is the topology. Okay. R1, R2, R3, R4 and R5, 5 routers. R1 connected to R2 via S0. R1 connected to R3 via S1 and R1 to R4 is S2. R2 to R5, R3 to R5, R4 to R5. So this is the network diagram. Get it?
Yes, sir.
Now scenario is R1 LAN. 2 destination is R5 LAN. How many paths are available from R1 to R5?
Three.
2.
3,
How many paths?
3.
3,
3 paths now.
Yes, sir.
So what are the 3 paths? Via S0 you can reach, or via S1 you can reach, or via S2 you can reach. If traffic is going via S0, what is the hop count?
1.
1,
S0 handover to R2, R2 to handover to R5. Hop count is
2.
2.
2.
Via S1, S1 handover to R3, R3 handover to R5. Hop count is
2.
2.
2. S2 handover to R4, R4 to R5. Hop count is
2.
which is the best path? That is my question.
So it depends on bandwidth and traffic.
Depends on bandwidth. Let's say it is a 10 Mbps. Let's say 80 Mbps. Let's say 70 Mbps. Now,
S1.
guess what? So point is, RIP will find the best path based on what?
Hopes.
8,
Hop count. And you can write here one more important point is hop count. In the bracket you can write. What is this point?
3.
Only. So RIP protocol will find the best path based upon what?
Hopes only.
1,
Fail.
Hop count only. It does not consider any other parameters. So
Series.
it will not consider how much bandwidth on the link.
Yes,
It
sir.
does not consider how much traffic on the link. So RIP will find the best path based on hops. That's it. If it's 2 hop, 3 hop, 4 hop, 2 is the best. That's all. It is not considering bandwidth. So it's a major drawback. It's a major disadvantage of RIP protocol is it does not consider bandwidth actually. If it is 1 Mbps, also it will be considered. It will not check actually. It is 80 Mbps or 1 Gbps also not considered. RIP will look into number of hops. Then why we need to maintain 80 Mbps links, 1 Gbps links in real networks? No need now.
Yes.
Anyhow, it is not considered. So it is a major drawback of RIP protocol. It does not consider bandwidth in metric calculation. It uses only hop count. Okay, then back to this point. Now, in this topology, which one will be the best path?
Anyone, sir.
Anyone. Which one? 0, S1 or S2?
First we will go by
all are equal.
All are equal, but traffic can go via which path?
0 most probably, sir.
0 first.
Why? So first link,
First
first
in, first
priority
out.
is
Yes.
like that?
P4.
No, we don't have that type of mechanism in RIP protocol, like first in, first out like that. No.
I think, sir, it will overlap because mean it will conflict because it will confuse.
I'll do one thing. Back to your technical example now. See, from R1 to reach to R5, we have 3 paths. 3 are best paths.
Yes, sir.
3 are good. 3 are equal. Then if I go with only one link, then complete load on that link, right?
Yes, sir.
Why can't we use remaining 2 links? So S0 or S1 is also best one, S2 is also best one. So anyhow, it is not considering the bandwidth you forget about. Leave it about this bandwidth, okay?
Okay.
Then 3 are equal, then why we can't use the 3 links?
We can use it.
Yes. So RIP will do that actually. It's a good
Distributing the.
advantage of RIP protocol is what
Yes.
RIP is doing is when there is a equal hop count, then a complete data traffic is being distributed to 3 paths. So traffic can go via S0, traffic will go via S1, traffic will go via S2. This is mechanism we call load balancing mechanism.
Yes.
Load balancing. But thing is, when exactly RIP will do load balancing?
Same hopes.
All
Hop
paths.
count is equal hop count, right?
Right,
Yeah.
sir.
So RIP supports equal cost load balancing by default 4 paths, maximum up to 16 paths. So load balancing is drawback or advantage?
Advantage, sir.
Advantage. So how many drawbacks we done? Advantages and disadvantages, tell me till now.
Disadvantage is half counts is only 50.
Yes.
Okay. Next.
It's not included bandwidth.
It's not included bandwidth. Excellent point actually. Yeah. Advantages,
Load balancing.
Load balancing concept.
load balancing. Next.
Choosing the best path.
Choosing the best path, it will done by all dynamic routing protocols now.
Utilizing
Open
the
standard.
access.
It's a classless routing protocol, support for subnetting, open standard.
Yes.
Correct?
Yes, sir.
Okay. Now we'll get to know more drawbacks in RIP protocol. That is why we don't use RIP in real time. So let's understand. So have changed the topology, guys. In static routing, we discussed R1 connect to R2, R2 to R3, right?
Yes, sir.
Here, I just connect a backup. Now from R1 connected to R2, R1 connect to R3. So it means from R1 LAN to reach out 10 dot network, how many paths are available?
2.
2. Can go via S0/0 directly. If it is fails,
Then R1.
R1 to R3, R3 to R2. Correct?
Yes, sir.
Yes. Similarly, from R2, how to reach R3? How many paths?
2.
2.
2. Directly 1 or R2 to R1, R1 to R3. So I just connected a backup actually. Okay. Now in this topology, R1 having 3 interfaces, 3 are directly connected. R2 having 3 interfaces, 3 directly connected, 3 directly connected. Now let us implement RIP protocol in R1. So if I configure RIP version 2, then R1 will start sending automatic updates to neighbor. So for R1, which node does our neighbor routers?
R2 and R3 both.
So it will start sending update to R2. It will send update to R3. To send this update, RIP will use one IP address. It is fixed for RIP version 2. That IP address is 224.0.0.9. 224.0.0.9 IP address RIP used to send update actually. And this is reserved. This is fixed for RIP version 2.
Okay.
So 224.0.0.9 is which class IP address?
Class C, sir. Class C, sir.
No,
Class D.
class D. Up to 223 is the class C. 224 is the class
24,
D.
yes. Class D,
So
yes.
class D
Multicast.
IPs are reserved for what?
Multicasting, sir.
Means RIP using multicast mechanism. RIP use multicast. What is multicast? What is unicast? What is broadcast? Huh?
At the same time, we can
Unicast means what?
1-to-1.
at a one time we can
1 to
send
1.
1-to-1, yes, sir.
So source and destination. If any one device is generate the traffic, it will reach out to directly destination. 1-to-1 communication. Broadcast means
1-to-many, sir.
1-to-many.
1-to-many. This is your switch. For switch, device 1, device 2, device 3, device 4, device 5, device 6, number of device connected. Device 1 want to communicate with device 6. Okay. So now here data packet is generated. If just a packet, what is the source device? 1. Destination device, 6, right?
Yes.
If data packet will reach to directly to 6, what type of communication is this?
1 to 1, sir.
Unicast.
Yes.
Unicast. Yeah.
Unicast communication is 1 to 1. Like PC4 want to communicate with PC5 and data packet will come to only to 5. Then what type of communication is?
Unicast.
Unicast only.
But point is now PC1 want to communicate with PC6, but thing is this packet is going to PC2, PC3, PC4, PC5, PC6, PC7, and there are 24 ports. 24 ports will be received. Then what we call this
Broadcast, sir.
broadcast.
Broadcast. Yes.
1 to all devices. How many devices in the network? It will receive all devices.
Yes.
Even this switch is connected to another switch. Another switch 24 ports also will be received. If switch 2 is connected to 3, 3 is connected to 4, 4 is connected to hundreds, then entire domain is being broadcast. Right? This is the broadcast mechanism. But the thing is, RIP supports which type of communication is multicast. And what is multicast?
One to
Same.
One.
selected money, I think so. Many.
Connect 1 to selected?
Many. Like,
Selected many means what?
To many. Many to many.
Many to many. Oh,
Yes.
so multicast means in R1, router A, I configured RIP version 2. In B, configured RIP version 2. In C, have configured RIP version 2 protocol. In E, I'm running OSPF protocol. In H, OSPF protocol is configured. Got it?
Okay, sir.
In D, I configured EIGRP protocol. In F, EIGR. In G, EIGRP protocol. But all routers are interconnected. C is connected to E, E is connected to H, even D is connected to A. All are connected, right? But inside that routers, protocols are different. The point is, in A router, there is one change. One new network is added. That is 9 dot network. You know what A will do? Actually, for A, which routers are neighbor routers?
BCD.
BCD.
E is directly connected, C is directly connected, D is directly connected, right? But
Yes.
router A will send update only to B, only to C. It will not send update even D is directly connected because of D is running
Different protocol.
different protocol. So means multicast means 1, 2, 1, 2.
1.
So it is sending to 3
1
and
to
it's
2.
sending to C, right? Not how to 1
1
to
to 2.
Many.
1
1.
to 1 to what?
1 to 2.
Why 2?
To many.
Example 2 routers, you're telling 2, man, right?
one to neighboring routers.
1 to a specific group actually.
Yes, sir.
Same.
Protocols if
So
they
in
belong.
entire domain, which routers are running the same protocol for that router zone, it will send update. Means 1 to a specific group. So A, B, C routers belongs to which group? RIP group. So if any changes in B, B will update to A will update to C. So communication also possible with the ABC only. Even E directly connected, D is connected, there is no communication. No database exchange actually. Because they are running with different protocols. So in entire this domain, how many groups are there?
3.
3 groups. RIP is one group. OSPF is one domain. I mean, domain means group. And EHRP is another domain. 3 different domains. So if D generate any traffic, the traffic will go to F, F to G only. So means 1 to a specific group. Got it?
Yes, sir.
So this is what we call multicast. So back to our three routers topology. In R1, we configured RIP version 2, correct?
Okay.
It's sending 224.0.0.9 IP address to send update. So this update will go to R2, will go to R3. What R2 will say? Who are you? What is this update? I don't know. I can't understand. I'm dropping it. Why? Because in R2 RIP is not running. Because of in R3 RIP is not running now. So they don't understand actually. But if you configure protocol in RIP version 2 here, RIP version 2 here, then this update is coming from which IP address? Update packet is coming with which IP address? 224.0.0.9 now. So this by seeing this IP address, R2 can come to know, yes, I belongs to your group. R3 also understand, yes, we are three routers are same group. Then they'll start exchanging updates automatically. So R1 will send update to R2, R1, R3, R3 will update, R2 will update. So three routers will start exchanging updates actually. Clear everyone?
Yes.
Yes, sir.
Let's say R1 is updating to R2 and R3, correct? So update means, what is update? Hmm?
Any new
What
changes
is
is there?
update in, what is update in RIP protocol is complete
Routing table.
routing table. Remember these 2 points, very important. That is point number 1. What is update in RIP protocol is complete routing table.
Routing table.
What type of updates in RIP is different? I'll tell you that. Okay, wait. So R1 is sending update means complete routing table. In routing table, how many networks are there?
3.
It has to send 3 networks. In routing table contain 16 networks, then
60 network will send.
60 it has to be sent. In routing table there is a 600 networks, then
100 it will send.
60 it has to be sent. 600 it has to be sent. No excuse, huh? Complete routing table. It has to be sent actually. Got it? So currently 3 networks is sending to R2. What R2 will check? 192.168.1.0. Not in my table. It is adding. It's updating. 192.168.1.0. 17 to 18. Not in my list. It's adding here. 172.18.0.0. 17 to 16. Yes, already available. You can ignore it actually. So these 2 networks manually into update or automatically?
Manually.
Oh man, it is not a static routing now.
Okay.
It is
Okay. Sorry.
RIP.
Sorry. Oh, sorry, sir. Sorry.
RIP means it will see R update. R indicates RIP updates.
Okay. Okay, sir.
Now R1 will update to R3 also. So what networks R3 will update here? 192,
192.168.1.0.
168, 1.0,
16. 70.
16.
72.16.
As RIP automatically, right?
Automatically. Right, sir. Right.
Yeah. Now R2 will update to R3. Means 10 dot.
10.0.0.0.
Remaining already updated actually. And here 192.168.2.0. Then R2, R3 both will update to R1. What networks R1 will update?
192.168.1.200.
17.
Right?
Yes.
Now R1, R3, R1, R2, R3. 3 routers are maintain up-to-date routing information. Any missing networks? Please check it and tell me.
All done, sir. I think only serial port. I think we are missing.
Where?
Serial.
No. All networks, just you check the networks. Any missing networks in R1, R2, R3? Simple, man. Total how many networks in this topology?
No,
One,
sir. Complete.
No,
two,
no network missing, sir.
three,
No network, sir.
4, 5, 6 network total, correct?
Yes.
R1 table, how many networks are available?
Six. Six table.
R2,
Six table.
R3.
Six table.
So every router are maintaining up-to-date routing information or not?
Yes.
Yes.
Yes. See, R1, R2, R3, three routers are maintaining up-to-date routing information. But now, is there any need to send update again to R2?
No. No.
No.
But RIP will do that actually. What RIP will do is, for every 30 seconds, R1 will send updates, complete routing table to R2. Same information. Already it has maintained up-to-date routing information, but it's still sending same information to R1 and R3. R2 will send update to R1 and R. All three routers, same routing table information for every 30 seconds, they keep exchange. Why this type of updates we call periodical updates. So there is some time interval that is 30 seconds and keep on updating. What we call this updates?
Radical.
Periodical. So what type of updates in RIP is?
Radical.
Periodical updates for every
30 seconds.
30 seconds. Advantage or disadvantage? Hmm?
Advantage.
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 Advantage. Why, man? Uh, in
System
first
will
day, first class, I introduced myself.
Said
My name is
disadvantage, sir.
Balesh. I introduced myself. I'm a Balesh. I'm a senior network engineer, like that. Introduced because in the day one we don't know each other, right? I introduced. Then you have update. You know my details actually. After 30 seconds again, I need to introduce myself.
No.
Again 30 seconds, I need to tell myself.
No.
no.
Why? Already you know, right? Already update you have actually.
Yes.
So that is the same point here. All routers maintain up-to-date routing information. Why you are sending same information again and again? Bandwidth is waste now.
And with
Okay.
workspace.
So that is a major drawback of RIP protocol is RIP protocol consume more bandwidth by sending periodical updates for every 30 seconds complete routing table. Practically understand that how much bandwidth is being consumed by RIP protocol. Because every 30 seconds, 24/7, update, update. Three routers are running continuously. Process CPU running utilization. Bandwidth is consuming. Get it?
Okay, sir.
Okay.
When really update required, man? When update is required?
When any new
Any changes? If a network is added, that give me that update. Or if any network is down, then tell me that what is network is down. If any link failure, tell me that link failure. Then we need to update really, correct?
yes, sir.
But
Yes.
here no changes done, not nothing. I'm maintaining up to date, but still it is sending complete routing table information for every 30 seconds. For getting the drawbacks of RIP protocol,
Yes, sir.
it does not consider bandwidth. Unlimited hop count, 16 is unreachable. Utilizing more bandwidth, consuming more bandwidth for sending periodical updates. And it is sending complete routing table as update. In routing table having 30 networks or 300 networks or 600 networks, it is sending as complete routing table. Got it? You can see complete routing table, send as update, And one more point is each update. So this is a routing table. And routing table having 1, 2, 3, 4, 5, 6, 7. Let's say there are 100 networks in routing table. It has to send 100 networks or only few networks as update. RAP has sent what? Complete routing table, right? It's
Yes.
total 100 networks. But thing is, each update can contain maximum how many routes?
25.
25.
Maximum 25 only. So what RAP will doing is, it will split in 4 updates. First 25 routes will send as a one update packet. Next 25 networks will send as a another update packet. Next 25 networks will send as a, because one update contain maximum is 25 only, but how many routing table, how many networks are there? 100 networks. So 4 update packets will send actually. And it is 25. Each update, what is the time interval for each update?
30
30
seconds.
seconds.
30 seconds.
So one
30
of the
seconds.
router is waiting for 98th network. One of the router 2 is waiting for 98th network. When router 2 will get 98th network? In first update packet, or in second update packet, or in third update, or fourth update packet?
4.
4.
Fourth. So RAP protocol conversation is faster or slow?
Slow. Slow.
Slow protocol conversation. Drawback. Lot of drawbacks in RAP protocol. That is why we don't use RAP in real networks actually. Then why I'm clearly explaining about RAP protocol means if you understand the RAP protocol drawbacks, then you can easily understand about next protocol, which is important protocol is OSPF. Okay.
Okay.
Yeah. Okay. So administrative distance is 120. I asked to remember administrative distance values, right? Static routing is 1. RAP is 120. Yeah, I'll tell you later on what is exactly, but you just remember at these points. Next, configuration part. Okay. So this is configuration like router RIP version 2, network space, network ID. That's all. So good thing in RIP is configuration is simple, very simple configuration. No subnet mask, nothing actually. Network ID. Directly connect network IDs. This is R1 configuration. How we can get directly connect networks? Open the routing table. Then you can see directly connected networks. There are 3 directly connected networks. Router, RIP, version 2 you need to command. You need to give this command. Otherwise it will affect in version 1. Version 2, network 172.16.0.0. This directly, whatever the routing table networks, this network is an offense. Router 2 networks, no need. Router 3 networks, no need. Only your router 1 networks is an offense. Enter. Next, 172.18. Next, 192.168.1.0. Done. R1 RIP configuration is done. Get it? Then R1 will start sending updates to R2, R3. So to monitor that updates, you can use this command debug IP RIP and wait for 30 seconds. We can see updates sending to R2, R3 on your screen. This is one update packet. Again, second update. See, RIP sending version 2 update. So like this, for every 30 seconds, just keep on sending update to R2 and R3. Okay.
Okay, sir.
Okay, sir.
So to stop monitoring this, you can use this command, use space all and debug all. But you can see here, it is just sending only. It is not receiving. Why?
Other side protocol.
Other two routers are not configured now.
Yes.
So need to be configured on 2 and 3 also. In R2, just open your routing table, show IP route. You can see all 3 directly connected networks. And you can implement RIP, router RIP, version 2,
Network.
network 10.0.0.0, network 172.16.0.0, network
192.
172.17.0.0.
Done.
Done. This is R2 configuration part. Like, we'll implement R3 also. Okay. Implement R3, show IP route, 3 networks, router RIP, version 2. 3 routers should maintain same version. 172 dot
16.0.0.
17. Where is 16, man?
17.
00
18 and 1.
18.
192
168.
168
2
2
dots.
dot 0. Done. This is R3 configuration. So I'm sharing these 3 routers configuration chart. You can copy from there. Now if we check routing table, show IP route. Before RIP, you can see only 3 directly connected networks now, right? Only C networks. But now you
6.
can see R networks, means RIP networks. Okay. Any more doubts? So try to practice RIP on 3 routers. If you have any doubts,
No.
ask me in chat. WhatsApp group. Okay.
Sir, could you please send me the WhatsApp link? Actually, I wasn't available.
Atul,
Yes, sir. 1 minute, sir. Sending.
Any more doubts, guys?
No, sir.
Okay.
Just 1 minute, sir. Sending it.
Yeah. Okay. Tomiwa, any
Sir,
doubt?
which is no doubt, sir.
Good. Are you practicing, man, regularly?
Sir,
No time. Are you practicing on all labs?
yeah, I'm practicing, sir.
Okay. Good. I'll ask you one day to share your screen and I had to show everyone. Randomly, I'll ask any one person to ask to share your screens and you need to show all the lab in folder.
Yes,
Okay.
Okay, sir.
Yeah.
Sir, please share the notes.
Oh, that it is not working, right?
Yes, sir. Please, sir, share it, sir. Actually, lot of notes making is pending, sir.
Drive Google Dot. I have lab manual is ready with me.
Yeah.
I have shared in this chart. You can use this lab manual for practices.
Okay, right, sir.
Yeah, if you open this link, in web link it will open actually, and you can access it permanently. This is lab manual. Okay, guys. I'll share the course presentation also and so on. Okay.
Okay, right, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thanks, right.
Thank you, sir.
Thanks, everyone.
Thank
Good
you,
day.
sir.
Bye, sir. Good day, sir.
Bye.